Alright, we live. I just taking in some stories and thing here. Hopefully everybody's inside now. Some points. One, some lives on this channel are slow and talking. That's how some lives are. And the problem is when you're watching those lives right before exam, you don't appreciate all the talking. If you want short and to the point videos, there are videos on this channel that are short and to the point videos. It don't make sense going and fight up with a video that I do 2 years ago that is just me talking to some students for long and then vexed because, I don't know, oh gosh, a little correct for that. Next thing, when is bio? And there we go. Tell me when is bio. So, things you need to know. This is short and to the point and sweet. I'm not doing any questions, I just answer it. I'm just giving you things that you need to know, just like what I do for technical drawing, right? Properties of solids, liquids and gas. Need to know that. Particularly that particles of a solid can't move freely because of why can't particles of a solid not move freely? So I'm giving you each topic and I'm giving you like the most common trope for CSEC. Let's get the answer there. You need to understand the difference between intermolecular versus other forces like intramolecular. This is not so much, so just check that out. Bias tomorrow afternoon. Lord. Alright, so arrange and increase in size, you need to know this. Solutions, then colloid, then suspension. And all the properties of these you should know them, especially particle size. So this is increasing particle size. First answer, people say because of strong forces of attraction. Attraction strong. The forces of attraction that is, they can't move freely, they're strong, right, between particles. So you need to understand this. Just take a little peep at that or look it up on Google. You need to know your order of particle size. If you're given two elements and you say this one has 10 protons, 12 neutrons, you need to understand all the different arrangements that come with this. 10 protons, 11 neutrons, 10 electrons, 10 electrons. What are these to each other? What are these things to each other? What are they called? And while you're on that, you need to know what is an allotrope, what is an isotope, and you need to be able to identify whether something is a cation or anion given them kind of thing. So bio after. The thing is I didn't prepare the bio. And the last time I do bio last year, I did it with my brother who have a degree in biology. And my brother not here now, so I'm too sure I could come through the bio. Don't fight me. It's been a rough weekend. And somehow I end up on Miraculous. By the way, close off the live chat, press like in the chat. I would like if you were somewhere else to get the notification that I'm going live. So close off the live chat, press like in the chat, and take a picture if you can, post it, and tell people there we go. Right, so this is called an isotope. Why is it an isotope? These are isotopes, because they have the same number of protons, different number of neutrons, which will give them different mass numbers. Same atomic number, which is number of protons, but different atomic numbers. Now, if you realize that the compound has same everything here, but you're seeing like a different number of electrons here. Now, let me see this had. Yeah, what is this? 2 and 8. No, don't like this. Let me see this is 11 protons, right? And you're seeing 11 electrons here, and then you're seeing 10 electrons there. This tells you that you're seeing what I have, right? 11, 12, 11, 12, 11. This one is 10. Which one is an ion and what type of ion it is? Which one of these is an ion and what type of ion it is? Those two things you need to know that like the back of your hand. Take it from the Cohen man. A bio session in the morning would be appreciated. Shoot me. A bio session in the morning would be appreciated, they say. I wanted to do these 2 sessions. It was just a disaster this whole weekend, and I had this obligation with my sister for this miracle strip, and that kind of just messed me up bad. Suspension colloid solution. Suspension colloid solution. It's the same thing. You just go from the opposite direction. But if you're going from increasing particle size, this is the smallest. I'm not really quarreling with nobody tonight, and I'm telling all the things. This one here would be a cation because it lost 1 electron. This one here would be normal. You know, this has 11 protons, 11 electrons. That means that's just a normal atom respecting its atomic self. This one lost an electron, so it's a cation now. This is like 11 protons. You understand? So it have an extra proton. An extra electron. It shouldn't have an extra electron. The number of protons is supposed to match the number of electrons, otherwise it's an ion. And if it lost, it's a cation. If it gained electrons, it's an anion. Enough of that, a weighting wise is sufficient. Next thing, you should know your notation. For example, if you see Cl1735, you should know which one is the atomic number and which one is the mass number. So which one is the atomic, which one is the mass number? You understand what's an allotrope? Same compound, different structural form. So compounds that form allotropes. This is asked. They like to ask what kind of compounds form allotrope? Sulfur, and what's the next thing you need to know? Carbon. And you need to know the 2 carbon allotropes, at least 2 or 3. 2 popular one is graphite and diamond, right? Also, you know it's an isotope. Same atomic number, different mass number, same element. Cation and ions, I explained already what you need to know there. So this is the mass number, the bigger one, because this has the number of neutrons included in it, and this is the atomic number, aka the proton number. So this is the number of neutrons plus protons. This is just the number of protons. We go forward. You need to know how to convert between mass to grams to concentration to volume. This is a really large topic. I have some nice videos on this topic, but the video long to learn it now. You actually need time to sit down and watch the video and make notes and try a question and things. So you should just have a little quick idea of how to do it. Let me see what kind of question. What mass of oxygen atom contains the same number of moles as 112 grams of sulfur atoms? Alright, that's a weird question. So people sent me some questions as well. Don't send any questions. What mass of, and I have real messages on my phone, I'm frightened to look at my phone. What mass of oxygen atoms. People stop sending me messages during exam time as well, during the actual exam. I don't even read my phone during it. Just so I can say I don't read my phone during exam time. Contains same, you know, kind of messages people like to send during exam time. Hold off on that, please. Please do some organic chem. I'm doing everything I need to know. That like a quick session on multiple choice, but we're speeding. What mass of oxygen atom contains same number of moles as 112 grams of sulfur? Now, if you need a quick to the point rundown on the entire organic chemistry, you could watch my whole organic chemistry playlist. I don't know how long it might take. It might take you an hour. So if you're real weak in organic chemistry and you want to just refresh every single thing because you need to know a good bit of organic, just watch the organic playlist after this. There is a no sleep, you're looking at it. What mass of, why is in the chat if you see my organic chemistry playlist already? What mass of oxygen atoms contain the same number of moles as 112 grams of sulfur atoms? Yes, the answer is 56. Because sulfur is 32, you don't need to know that it's give you the mass. And oxygen is 16 by itself. Not oxygen gas. Oxygen atoms just by itself is 16. Oxygen gas, you have to multiply by 2. O2. So this is 32, this is 16. So if you're telling me same number of moles as this amount of grams, well, 1 mole of this has twice the weight as 1 mole of this. So I just divide this by 2 to get that. Some of the answers, you don't need to go through the whole process of going between, like, this is between, I say mass and grams, on the same moles and grams. You understand what I say? Mass and grams, same thing. This is converting between grams and moles, but you don't need to go through the whole formula and everything. Multiple choice questions give you a kind of way out to try and think about the question very quickly. Alright, that's enough of that. What makes H2SO4 a stronger acid than ethanoic acid? What makes sulfuric acid a stronger acid than sulfuric acid? What makes sulfuric acid a stronger acid than ethanoic acid? Sorry about the time, but this video was just not allotropes, allotropes. So you should know why a stronger acid is stronger than a weaker acid. Like a weaker acid would be this, or carbonic acid, or I think that next weak acid, but they're the popular weak acid for CSEC, and it ionizes to a greater extent, or it ionizes fully. Well, for all intents and purposes, fully. So this one ionizes more than this one. This one only partially ionizes, right? So you ain't getting much of this. You ain't getting much of the hydrogen. That hydrogen H plus hydrogen ion popping out that much. You ain't getting much protons for the same number of moles. Alright, turn the page. Properties of metals, nonmetals and salts. You should have a way around that. Why do salts like sodium chloride have a high melting point? So why does a salt have a high melting point? You should know properties of metals and metal salts. This is one example of how you can ask why would, and a lot of things in chemistry will be asked. They try to ask you to state the list, but you can't state a list in multiple choice, so they'll tell you which one is not correct in the list of A, B, C, or D when they ask you to state a list. So why does this have a high melting point? Strong electrostatic forces, because it's between the ions, right? So between the sodium and chlorine ion is strong electrostatic forces. Alright, so they'll give you some new element very likely. So let's say the new element is X, and they tell you it acts like, let's say it acts like sodium. X sodium, no, X sulfur. X and sulfur will give you what? So basically, they're just trying to see how good it is with a metal or a non-metal in terms of reaction. So X acts like sodium. What would X and sulfur form? Well, you just need to know, and this is very important. This is one of the things that you have to know inside out. You see the table of ions? Learn that, my brother. Learn that, my sister. Some people go through and they don't know their anions and cations. If you don't know that, cram off before the exam. Just make sure you know that, because that will be tested. Your knowledge of that will be tested in things like this. Did I spell sulfur with an E? Sulfur. Sulfur. Alright, so you'll get X2S. Sulfur is 2. Sulfur is 2. Sulfur is 2 minus. And X sulfide. And sodium ion, well, that is 1, right? So X2S. X2S, right, great. Know the cations and ions table, yes. What is a metallic bond? You need to know the definition for that. Ionic bond. Alright, so metallic bond, let me tell you the keyword to look out for when you're talking multiple choice, right? Ionic bond, not really much asked, but I'll show you the keyword for that. Covalent bond, I'll show you the keyword for that as well. So the keyword for metallic bond, you're looking for pool or C of mobile electrons. For this one, you're looking for donate. Actually, this is the one that is be asking donation or giving of electrons from metal to non-metal. Very important. So donation or giving. So in ionic bonds, remember, give the electrons. This stays here. Go electron also, they become charged, and there is an electrostatic force that keeping them together. A covalent bond is a sharing. That's the magic word. Sharing of electrons. So they actually, you keep your electron, but we just link up. It's still yours, this one is still mine, but you're just full up by just pretending that they are not, or it's a kind of weird relationship them dealing with it. Right, enough talk with that. Oh, you need to know, so periodicity, you need to know why elements are in same groups. What makes an element belong to the same group? In same group and period. Close the live chat, press like. Close the live chat, press like on the video, share the video with somebody. We get them views up. Normally the Chem live is be like 700 concurrent for before our exam. Alright, why are elements in the same, well I know it's late, 10:19. Same group, why are they in the same period? So elements in the same group, same number of valence electrons, or outer, or valence, or outermost, or whatever you want to say, outermost shell, outer shell, electrons. Why would you be in the same period? Right? Why would you be in the same period? You'd be in the same period, same number of electron shells, right? Same number of electron shells. Sorry about the time, people. It's just the way it is. Oh, they love this diagram. I feel like I've been seeing this diagram for my whole life. What am I drawing here? What is this? They love it. They love it. It's like, What's this, my friends? So you know that is your graphite, and you should know graphite used as a lubricant because there's an allotrope of carbon, and that's why not why it's used as a lubricant, but because the layers slip over each other. There's three strong covalent bonds, and then there's this kind of weak bond that that can break, right? So cool. So you know that is graphite, know your allotropes, your common allotropes. As I said, sulfur and carbon, those are the two we love it. By the way, CSEC in love with this, I tell you, they're in love with this. When you see this tomorrow, just remember I tell you, CSEC love graphite. They will draw graphite every single year. They love this graphite. They bring this in the paper too. Paper 1, they will send you this on a postcard for Christmas. They love graphite. So you need to know 3 definitions of acids. The most important one, because this is the one students forget and they like to test, is that it's a proton donor. Right? Go in your textbook and check out the next 2 definitions. See if you get 2 other definitions. Make sure you have it. Qualitative analysis, stable gases. So write this down. Check out the other 2 definitions for acid. But definitely know that this is a definition for an acid, right? Or it donates hydrogen ion, the hydrogen ion, which is a proton donor, right? Qualitative analysis. A lot of stuff can come on qualitative analysis. I know it's what I used to do was like all now so, like not all now so, like in this morning I will learn off everything to just freshen it back again. Because somehow I don't remember the entire qualitative analysis. I'm not trying to memorize every single thing qualitative analysis. So I just used to, like the day before the exam, make sure I top up on everything, make sure I understand the reason and the equations behind everything. and then just top up on it before the eggs. Just, you know, make sure I can repeat it word for word. I like the word for word thing, you know, this gas release, da 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 da. Anyhow, so let me tell you some kind of things to know. You see the table of the gases and how to test for gases. The two most important ones, the three most important gases. What are the three most important gases that CSEC loves and sign a contract with? Hydrogen, oxygen, and not oxygen. Hydrogen, ammonia, and carbon dioxide. You see them three gases in terms of tests? Make sure you know the tests. This is the only let's call it alkaline gas, or gas that will turn moist red litmus paper blue. So that's the test. This is the test for ammonia. So this is the most loved because it's so unique. You know, turns moist red litmus blue. All the rest is turn blue litmus red, right? Or nothing is happened. So ammonia, make sure you know that this is yeah, everybody know ammonia. It's right. CSEC, you see this is going to come. If you hear and you take in your last minute coin spring a cash course, and yes, write this down. Write this down. Make sure you know the test for ammonia. Make sure you know that ammonia, and next thing with ammonia and ACL, what does happen, right? In the chat. That's popular. That's the things in Chem for CSEC that is just like bread and butter. Ammonia and ATL. They have the thing when you let go one and you let go next one and they come together and they make something in the middle. Write it down in the chat. So what's the test for hydrogen? Outside like it's printed with a pop sound because it's really an explosion going on there, but because it's just a test tube and you do so and you let go the hydrogen and you pay a splint, boop, and it out with a squeaky pop sound. You say, hey, hydrogen boy, and feel good and thing, but it's actually an explosion. Carbon dioxide, test for that turns lime water milky. What's the formula for lime water? Let me say it one time. So calcium hydroxide. Right? Calcium hydroxide is the formula for lime water. Yes. Yes, it is. So you need to know that. Dense white fumes. Very good. So NH3 plus HCl, dense white fumes. Okay, let me go forward. Moisture litmus blue, ammonia gas evolve. Oh, so if ammonia gas evolve, it means that the ammonium ion is ammonium salt. Is ammonium salt, ammonium ion. Yeah, right? So something NH4. Why would why does calcium, when it forming an ion, form Ca2+? Why does calcium, when it forms an ion, form Ca2+? Why not Ca2-? The reason is this has two valence electrons, or two outer electrons. Two electrons in the outer shell. Right? So you will lose the two electrons. It's easier to lose the two electrons than to gain how much? 6 to try and get a nice full shell. And all them protons had to pull all them other 6 and hold them in place. Nah, it's easier to just let the 2 go now, man. Let the 2 go. So the 2 could go, and if the 2 go, you'll end up with 2 protons exposed, so it's calcium 2+. So that is the reason. Because calcium has 2 outer electrons. Similarly, why does Cl minus have 1 minus? Why does Cl minus have 1 minus? Same thing. It has 7 electrons in the outer shell, so it's easy to just gain an extra electron. So it's because of how much in the outer shell, right? We talk about that. That's important. Everything I talk about here, well, I know why now, right? I know why now. Alright, so understand how RAM works, relative atomic mass. So for example, there is the RAM of CO2 for 1 mole. So 1 mole of CO2 is 12, is 16 times 2, 32, 44, right? So this 44, you're supposed to know this often. 44 G's for 1 mole. So if I tell you now, yo, I measure something here and I have 88 grams of that. What in the world are you doing with 88 grams of but anyhow, so let's say I have 88 grams of this soldier. or maybe it's some ice or some kind of dry ice. So let's say I have 80 grams of carbon dioxide. How many moles would you expect? How many moles would you expect? Well, if 44 grams is 1 mole, so you see you don't really need to use the formula too much. If you understand maths and you can check it out and you just have your eye chemistry and know that this is 2 moles. Nice. Increase, only things that increase rate of reaction. 4 things. That way, like for example, look at that. So which of these things do not increase the rate of the reaction? And they'll put on a list: surface area, temperature, concentration, and then they will see something stupid like I don't know. What to say by? What to say by? Something ridiculous, right? I can't think of anything stupid. They might use something with the equation like removing this from the actually if you remove the products, that is sometimes help the reaction. Anyway, so you know what increases the rate of reaction is 4 things. 4 things that increase the rate of reaction, or they might use the opposite. So which of these increase the rate of reaction? 4 things: surface area, temperature, and they might say lowering the concentration. But what does increase the rate of reaction? Not increasing the concentration. So surface area, temperature, increasing the concentration, and of course the wild card catalyst. So surface area, temperature, concentration going up, temperature going up, surface area going down per particle now. So actually this going up. So increasing the surface area by making it finer. So even though the surface area going up, the particles itself, in fact I used to do this all the time. My mother used to be like, what the hell are you doing? I used to take powder, flour, kitchen flour, and do so and dust it over the stove. And just used to light up like this. Boom! So flour is flammable. When you get like, anyhow, you know what I'm really talking about, man. Catalyst. Alright, so the presence of a catalyst could help. Wow, watch this word. Take that down. You need to know your pH diagram, so the course of a reaction. For example, if you had X and you add in Y, so you say Y added in terms of like cm cube, and where you have your pH, and if you see something like this and it go from low, now you say like 1 to 13, it means that you started off with a really strong acid and you finish with a really strong alkali. If you see it went from here to here, it means you started off with a weakish acid. Let me say this was 5. A weakish acid, let me put 6 to make it look even weaker. A weak acid, weakest of the weak acid, and then you wet him down with some strong alkali. You know, you catch the drift. If you start off with a strong acid, but you know you only put a weaker alkali, here, finish off there. Every time you're adding Y. But keep in mind, if you start here and end up here, sometimes you could start like here with the alkali and you're adding the acid, which is really add the acid because one of them is at the top. And anyhow, both of them can be problematic. Back in the days, they did not know pipettes, suck out them kind of thing. We used to, you know how much acid we suck up like that? I'll ever get through that? Anyhow, so you have Y added. So it's very important to know the one that added is the finishing, and the one that started off would be here. So X in this case would be a strong acid. I'm just putting S for strong, and Y would be a strong alkali. Why isn't it if you understand that? Sorry, yeah, I start so late. But we finishing before 11. That's still good time. And you could always watch it in the morning, and I'm making it under our common allotrope solvent carbon. When is fractional distillation used? Why is fractional distillation used? You need to know that. Fractional distillation. I would just take a little peep at the fractional distillation diagram with the bubble caps and thing. I know in my days CXC loved bubble caps. So you need to know like that the less dense goes up and the more dense would say put, right? So the less dense will remain a gas and go up, but the more dense, the less dense goes up so up the fractional fractionating column, you'll have less dense here and more dense here, right? So cool. And fractional distillation is used to separate different densities, liquid, like different densities in the liquid, right? So like if you have a density here, liquids are different densities. That one I want to say, that one I want to say. So refining crude oil, liquid, air and oxygen, separating ethanol from, yeah, when it ferments, yeah, we're taking all the ethanol, liquid fractional distillate. And not for chemical reactions. Not for chemical reactions like converting alkanes to alkenes. Biosulfur real. I feel like I need to do bio. It's a major code cracking in bio. You just go on the student hub and you organize yourself, you know what I mean? Study with the students. Yo, I just have a couple more pages to go. Actually I have a lot of pages to go. What do you have? 2 more pages to go. So you need to know your reactions. We have with it. You need to know your reactions with metals. Like there's this table in your book with like metal plus water. In other words, the reactivity series. There's a reactivity series in your textbook and they show you a reaction with an acid, with water, with something else, with oxygen burning, how it burns, whatever. You need to browse that. Just take a browse and especially metal and water. For example, calcium plus water. This is a popular question because calcium is such an interesting one in that it creates lime water. So you get calcium hydroxide and then you can ask more questions on the lime water. You can ask some gas bubble in the lime water and it didn't. You don't understand that? Calcium hydroxide and H2 gas. This gas will out. You see, this is an interesting one. You can just build a whole set of questions of calcium. So calcium and water is an equation to watch out for when you're learning this. Make sure you know your metal plus water. Make sure you know like the reactivity series. Where does hydrogen fit in the reactivity series? Who hydrogen is above and who hydrogen is underneath. So hydrogen will be roughing up copper, but hydrogen will not be roughing up zinc. You understand what I'm saying? Important. Important. Hydrogen will be removing copper. Copper can't get rid of hydrogen. So copper can't rough up no acid and say give me hydrogen. Copper you know, replace hydrogen for the acid to form a salt. Copper really deal with that too much. Copper be low hydrogen. What more I could say about this boy? Generally this will have a alkaline pH. Plenty could, as I say, plenty can be asked for this equation. You can say what is the pH of the water, of the product? What the gas? What's the test for the gas that's emitted? If you bubble carbon dioxide through the liquid, what will happen? That kind of thing, right? Make sure you know all the answers to those questions. Energy diagrams. Energy diagram. Why isn't rate how much you understand so far out of 10? If you learn something, if you're verifying where you need to know, that kind of thing. Energy diagram. You have your reactants, you have your products. If you're seeing this kind of situation taking place, that the products have more energy, endothermic. Products absorb energy from the environment. If you see it go the other way, endothermic. Products, the reaction give out energy to the environment. Nice. So no endothermic, no exothermic, just the general idea. Know how the graph will look like if you put in a catalyst. What difference will happen in the graph. Figure out oxidation numbers of weird compounds, a popular one. SiNa2, SiO3. You'll ask what is the oxidation number of silicon ion. You always call it silica, or I don't know. So where's the oxidation number there? You know where's the oxidation of this? This is +1, the oxidation of this is -2. 2 by 3 is -6. 1 by 2, so this is +2. So take this and that, so you're ending up with -4. So where does this have to balance off that -4? So this will be +4. Right, simple thing. Electrons, they could bring different things and make sure you understand. This is why I need to know the table of the anions and cations. There's one table like you have to learn. Even if you memorizing questions and them kind of thing, learn that table. What is the oxidation? Blah 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 blah. Anything I can talk about on this, boy? Okay. So electrolysis can come in some way, in some numerous ways, like the extraction of aluminium. One of the things I like to talk about, this is like a star question. In the electrolysis of bauxite or the extraction of aluminium, something is react with the anode. The anode is carbon, but something is still react with the carbon anode. The oxygen is be oxidizing the carbon anode to form carbon dioxide. That's why I had to replace that anode every now and then. I just now tell you a big important thing, right? There's like a wildcat there. Electrolysis of brine. Electrolysis of brine. So you need to know electrolysis of brine versus electrolysis of, well, you know brine is concentrated NaCl, concentrated salt, salt water concentrated. And then you need to know the difference with the electrolysis of diluted salt, NaCl, table salt, NaCl, right? Not really table salt, but you catch it there. You have impurities. NaCl and concentrated. So the difference between the two, you're still going to get what? You're still going to get H plus at the cathode. Cathode, cations go to cathode, anodes, anions go to anode. You're still going to get H plus at the cathode, both of them. Double check that. I think, but the anode is the interesting part. The anode, OH minus when it's dilute, because it's plenty water, is basically the water where you just be removing water from the system. You will just be removing water from the system when it's dilute. H going so, OH going so. Well, you know it as OH, but you'll see some more about that in A-level Chem. Anyhow, so, but if it's concentrated, H will go so to the cathode and Cl, chlorine, will come off at the anode. Big things, big things. Chlorine gas, so Cl minus, make a next Cl minus, make a gas and bubble off. And you need to know that that is chlorine gas flying off there. Okay, how to dry gases. Now the important one you're gonna see across. Oh my gosh, I just take a picture. Really going on with me, boy. How to dry. Good thing I never memory card. Gases. How to dry gases. And the delivery. Some gas less dense, so some have upper delivery. Write it in the chat. Some have upper delivery and some gas more dense, so some have downward delivery. That's one. And how to dry gases. The important one is ammonia again. You're not going to dry ammonia with concentrated H2SO4, the common drying agent. Why you're not going to use that? It can react. So what you have to use instead? I forget what it is. Copper. Dry gases. I think this put anhydrous copper, but that is not the answer. One thing they like to ask. So calcium. I'll write it in the chat now. Calcium. How to dry is calcium chloride. How to dry. Write it in the chat. Verify that it's calcium chloride. I'll just go in delivery of preparation of gases. That's the chapter in your book or whatever, preparation of gases. How to dry the gas and which one in upward delivery and which one in downward delivery. I think it's calcium chloride to dry calcium chloride to dry the gas. Yes. You're not going to react with it. Yeah, because calcium is strongly calcium above. Calcium chloride, I think it's calcium chloride. Calcium oxide. Calcium oxide. Is it calcium oxide? Right, people saying calcium oxide in the chat. Check and see if calcium chloride is one too. I think calcium chloride. Me no. Calcium oxide, calcium chloride. Why not? React, maybe not, maybe not. Calcium oxide, you want to dry the gas, you want to get rid of water. So let's say calcium oxide, whatever. I spent too much time on this. Reactivity series, make sure you know that hydrogen does not replace copper. Alright, so when you're going up the reactivity series of metals, the higher you are to the top, the more electropositive you are. So like calcium, highly electropositive, potassium, sodium, highly electropositive. So as you go up there, you get more electropositive. As you go up, you get less electronegative. As you go up the reactivity series with like the halogens, non-metals included, you get more electronegative. So the most electronegative is fluorine. Fluorine is a real bad boy. Fluorine is a gangster. So fluorine at the top of electronegativity there, just liming right there. And the most electropositive would be, I don't know, the bottom of group 1 or something, which we don't really talk about them so. But like we say like potassium, sodium and calcium, most electropositive for us. Alright, how much more pages, man? 2 more pages. How long is this taking? I think it's taking a long way. So they'll give you like natural atoms and ask you which one could form an alkali, which one could form an acid. Obviously none. So if you have Al, C, N, which one will dissolve to form something that acidic. I'll mess up this note. ALC. Oxide. Which one forms an acidic oxide? Does nitrogen form an acidic oxide? Does I don't know if it's that I wanted to say, does nitrogen form acidic oxide? Nitric acid. Nitrous oxide, not acid-base properties. So you read this one forming the acidic oxide. Maybe it's that trying to say, maybe it's that, maybe it's that trying to say. Anyhow, let's keep going. 15 more minutes. Hold it up, people. Keep it up. You also need to know properties of metals. I mentioned already. So they actually like list of properties of metals, or like why is sodium a metal? Why is sodium a metal? And sodium is not a metal because like it's soft or reactive, or it has a low melting point, which sodium does have, but that's not why it's a metal. It's a metal because of the whole list of metallic properties, like what? Like the whole list of metallic properties, right? Reacts with acid to form a salt and hydrogen, something like that, right? So there. You need to know alloys. Alloy is mixture of, an alloy is a mixture of elements, mixture of metals. Must be metals, mixture of metals. In the extraction of bauxite, why do we use cryolite? 10 more minutes, people. In the extraction of bauxite, 10 more minutes and I'm finishing. In the extraction of bauxite, why do we use cryolite? Make sure you just know your extraction's good. I wonder if they still bring iron. Yeah, if they still bring that, no that good. But I went through all of this already. By the way, I went through extractions and I went through all of organic chemistry. You can watch it on fast speed and just guns it. If you still have energy, like if you're sleeping today and you wake up to study, them kind of people, watch the organic, watch the extractions with you. You can even watch you from zero to hero, but keep in mind some of those lives from last year before, long, and a talk real plenty. Don't go on it and argue, that talk real plenty. What's the most important ingredient in chlorophyll? Yes, so you add the cryolite to lower the melting point. The most important ingredient in chlorophyll or constituent or thing in chlorophyll is iron. Because you're trying to tap. Is iron? No. What's the most important thing in chlorophyll? The most important thing in your hemoglobin is iron, but the most important thing in chlorophyll is what? Constituent of chlorophyll. That's nitrogen. Was it magnesium? Was it magnesium? Why isn't it chat if it's magnesium? Most important metal there in chlorophyll is magnesium. So I wasn't wrong, I corrected myself. So magnesium. Who making that noise? Magnesium. I say iron, yes. Iron is for hemoglobin, so you need to know that one too. And magnesium is for chlorophyll. I was just testing y'all, non-metal properties. Well, you need to know redox and understand. I do some of this already in the channel, long sessions. Reduction and oxidation. Who makes good oxidizing agents? Who makes good reducing agents? Non-metals do not replace hydrogen in acids to form salts. Metals do. Right? Non-metals don't do that. So non-metallic properties, them kind of thing, have that down. Two oxides that form acid rain. I used to put all the carbon oxide all the time and get it wrong and get vexed with that. Carbon oxide just have a small part to play. Big boys is sulfur and nitrogen. So the sulfur oxide, sulfur dioxide, sulfur trioxide, and nitrogen oxide. Those are the. This is all you know by now. Everything I'm saying here important. Let's go into the organic now. Okay, before we go into organic, what to add to make this happen? To make this happen, add aqueous NaOH. They'll always play around with things like this just to see how good your equations are. I put sulfur again. Why keep writing sulfur like that? Sulfur? Oh no, I didn't. Are they trolling me? I'll message it. Oh, they just okay. Sulfur. Alright, so aqueous NaOH there. So N goes with him, which would be right. Oh, so you need to know your replacement reactions. Let's call it. Anyway, let me just keep going. Homologous series, I just doing this quick because I have a whole thing on organic chemistry. I just browsing this really quick. Homologous series, what makes them the same? Common properties. Common general formula. Do they have the same empirical formula? No. Do they have the same general formula? Yes. Know all your formulas. Structural formula, molecular formula. And keep you gotta know more about the structural formula, fully displayed and all that kind of thing. But there's structural formula, molecular formula, empirical formula, general formula. know what makes what. Okay, let me just check like with, let me say we are doing, what is that? Ethane. So structural, just imagine each and every one of them there, right? This one here would be molecular, this one here empirical, this one here general is called a general formula, right? Only sometimes the knowledge little ancient here. Remember, maths and admaths is my thing. Yeah, all members differ by a CH2 group. By the way, keep watching the chat. The chat is be giving out some other ideas I need to think. I just cover in the whole general thing, but there are some good things there. Different empirical differ by a CH2 group. That's very important. Nice chat. All you real clicking these days, I love all you too bad. Know the difference between alkanes and alkenes. That is a number one love for CXC. Alkanes and alkenes. One is substitution, one is addition. One will do so and add up, one will have nothing to break, no double bond to break, so he have to substitute slower, right? So one will burn with a sooty flame because it has plenty carbon for it have a higher ratio of carbon, and one will burn with a more clean blue flame. Alkanes, we good boy there, right? Important things. Know how to identify. They'll always do two bromo ethane or ethane, 2 bromo butane. How to dry this? C beautiful. 1, 2, 3, 4. So if it's 2 bromo, don't put the bromo here. I mean, you don't need to dry it, you just need to identify it. So your bromine will be here on the second one, or it could even be here too if you count in this way, right? And all the rest is that kind of thing, right? To know how to, you also have different type of, let's call it isomers. Must know. A question must come on isomers. You have different type of isomers, like you have functional group isomers and then you have structural isomers. Meaning, if you take the bromine now, and put it here instead, and everything else is H's, those are isomers. This one is one, well, this one is just bromo ethane, like say 1 bromo ethane, right? It's on the number 1. If you put this one on here, it's on 2, so those are isomers. Different structural formula, same, let's call it empirical, same molecular formula, different structural formula. Or you can have the branching. So know your isomers for real. Substitution, addition, know the battle between alkanes and alkenes. I talk about that. Structural, molecular, empirical is like when you break down the molecular to the lowest ratio. I think that used to be a question, right? So like you have the molecular, so if you had, I just picking up something, X4, Y6, empirical will be like both of them divide by 2, so X2, Y3, empirical formula. This is more important for when you're doing quantitative analysis, and again a kind of ratio setup, and then you can have the empirical formula of whatever it is. Which you all wouldn't have to do unless you're doing chemistry for A levels. Chemistry for A levels was the nasty, for CAPE was the nasty subject I've done at the CAPE level. After that I was like, enough of Chem. I could go forward in life with physics, maths, but I see Chem, that is enough. That is enough writing. I'll keep that. If you like Chem, go ahead and do the Chem. Go ahead and do the Chem. It is a beautiful subject indeed. I just you know, although I do a lot of teaching of Chem CAPE back in the days. Anyhow, alkane, alkanes don't really react with every and anything. Alkenes, if you go on that's something you note in your textbook, you go on the alkenes and you check what it reacts with. A whole alkenes, a whole heap of things. Alkanes not so much. Alkenes is just, you know, substitution. Alkenes are adding on to. Alkenes want to react with everything, brother. and go everywhere. So alkanes can react. Alkanes when you react with hydrogen or a weak acid or water per se, but chlorine or fluorine, which you already deal with that T2 band, maybe bromine, you could get reactions with that under certain conditions. Learn your conditions and learn that they could react. Alkanes are saturated, alkenes are unsaturated. Duh. But an easy thing that can be asked a lot. It depends on what engineering. Like if you're going to do mechanical engineering or civil engineering, you really need that much chem on it. Get some science of materials, which can be a little bother for you if you didn't do much chem, but not too much of a bother. If you're going to do chemical engineering, big man, do chem. You're going to save your real stress. And so, yeah. Chemical, anything with all the geoscience and that kind of thing, do chem. Electrical, not so much. Computer and electrical, not so much. Computer and electrical is kind of like the way to go if you're going engineering now. That's like the highest demand, safest route. Somebody, unless in Guyana or Electrine, coming up, cracking. You need to know the products of cracking. When you crack a long chain, you end up with short and long alkanes, right? Short and long chain alkanes, like a break. Cracking. Know your products of cracking. Just double check that for me, because that just went straight on memory, that one. Cracking, your products of cracking, you need to know that. Have that as a note. You need to know your products from cracking. Full polymerization must come. They must ask you something on addition polymerization. Well, you know addition polymerization is for the polymers that build off of alkene. Big man, just go and watch my whole video on polymers, please. Every single thing I do in that video important. Let me just talk about it in general form, because I shut it down and I can't really remember stuff 100% and I don't want to tell you anything now. So esterification, alcohol and organic acid. Know what is esterification? Condensation, polymerization. The chat will give me the damn thing. Small alkanes and alkenes. Small alkenes, alkene and alkene. So one is double bond off. So one is break and one is from the double bond, and then one is from, right, so something like that. Thank you. The chat corrected me there. Thanks, chat. And esterification, alcohol and organic acid, amino acids, building block, condensation. Know what is condensation? Condensation, polymerization, where you get something popping out, condensing, normally like water or something else. A small molecule. Addition, polymerization, nothing is pop out, they just burst and attach. So it's have a double bond, it's unsaturated, forming long chains, right? Some weird reactions you need to know is the photosynthesis reaction, anyway, biology too, so know your photosynthesis reaction. And the next one is the fermentation reaction. C6H12O6 giving you chukuna, CH3, no, not chukuna, that's chuku, plus what is what do you do? Carbon dioxide. 2,2. Right, so this reaction, big boy, a very important fermentation reaction. And we'll call that hydrogen. Oh, what a major constituent. You see the whole, like the uses of all the things in the fractionating column for refining natural gas and no, for refining crude oil, know that. Major constituents in natural gas is methane. Major constituent in natural gas, methane. If you need to know more about organic chemistry, go and watch my organic chemistry video. That is my recap for there. How long did you make? Did you make the hour? Exactly 1 hour as a boss. So this is 1 hour condensed, really tight, with like usual things which will pop for CXC, usual things you want to check your bases on, usual things lessons teachers from back in the days will prime up their students with just to make sure you're covering all the bases. It's very late, so let me not take too much time talking anymore. You could go and check. Chukuna, that's how I always used to say it. Just chuku. So it's ethanol. What I do wrong? I say something wrong? Yeah, there's a 2 in front here. What if I help you remember things, the reason I remember so much and thing is because I shoot everything like a whole party. There's just a party going on in my mind all the time with all these information. Look, yeah, blessings for everybody. You can just take a double check on the things that you felt weak on when I was speaking here. Make sure you get sleep in. And very sorry if you don't see anything pop for bio, but bio is not the hardest science. Let me just put out there. I don't like to say these things because some people just get trouble with certain subjects, right? Some people bio might be real thunder for them, but bio is just for CXE. Bio for CXE is a distinction with it to happen, especially if you just need multiple choice. Anyhow, some of the answers in bio is be close. That's the only problem, I remember that. Out of all the sciences, some of the answers be really damn close. It's just be like thinking. So it's hard to get under 50 out of 60, but it's hard to get total because some of the answers kind of bootleg. Anyhow, bless up, love and blessings. Till we meet again. Some of you all, I may see some of you all in some of my lessons classes coming up for keep. Look out for that. I intend to try and provide a lot of classes to help students, especially during this period. You can follow me on Instagram if you want to keep abreast with that. Sorry about the timing again. This weekend was a nightmare for me. After I finish this, I have to go and do a lot of work for my private classes. And press like on the video.